Hey guys, in this video I'm going to show you how to use this template spreadsheet that I've made for you and how to make your scatter plots. So really quickly, this is a template that I made that has a lot of formulas in it that'll do a lot of this math for you. So let me really quickly walk you through how it works. You're going to take your data from your notebook, from your experiments that you did with your car, and enter it into this spreadsheet. And it's going to do a lot of calculations for you, and then you'll be able to make a really cool scatter plot. Now notice here at the bottom, first of all, that there are two different spreadsheets. One is green, one is orange. The green one, notice how it says mass versus motion. This is your mass experiment. The second one, force versus motion. This is your force experiment. So let's go to the green one, mass versus motion. Now we're just going to enter your data in it. So you should have the mass of your car in grams as one of your pieces of data. So you're just going to enter that in whole numbers. Do not put anything other than a number in there. In the column heading, it already says grams. So we know that 56 means 56 grams for everything in this column. Now the second column, notice how it's gray. Everything in gray, you do not enter anything into. It does the math for you. So anything in gray, you do not type anything into. So I entered 56 grams. It automatically converted it to kilograms, which we'll use later to calculate the force. Now, the force that you gave your car, this is whatever you set the force to. So if you had a rubber band car and you counted the number of turns around the axle, then that's what you're going to enter in here. So for this experiment, that would have been your control variable, so it would be 7 for all of these in the whole column, or whatever you set it to. The next column, this is the distance that your car went in meters to the nearest centimeter, so to the nearest tenth, hundredth of a meter. So say our car went maybe 4.96, we'd enter that. Now, I made the seconds column, the time column, in yellow because not many teams recorded time, which is okay. If you did, you're going to enter your time here in seconds. Maybe it was 2.33 seconds. Enter it there. Now, if you enter your distance and your time in meters and in seconds, this column will be able to calculate your velocity for you in meters per second. And before I post this template, I will make this adjustment so that it only has 2 decimal points, 2 decimal places. Okay, next column, that's the acceleration recorded by the microbit. Almost all of you were able to do that, so that's where we'd enter the value you got from the microbit, say 968. Now watch, when I tab through the cell, the next one automatically calculates the acceleration in meters per second squared. So we have to do a little conversion to go from 968 thousandths of the acceleration of gravity, or 968 milligravities, to 9.49 meters per second squared. Those are our units for acceleration. Now that we have mass in kilograms and acceleration in meters per second squared, if we multiply mass in kilograms times acceleration in meters per second squared, making sure that those are the right units, then we'll end up with force in newtons. So that's what this last cell does. It takes C2, where's C2? That's our mass in kilograms, and multiplies it times I2. Well, that's our acceleration in meters per second squared. Then you get your force in newtons. So you can go and enter that for all of your trials. I gave you 18 rows for this. I don't think anybody has more than 18 rows of data. If you do, I can show you how to copy these down. It's very easy. And if you don't need all these, you can delete the columns you don't need. So if I didn't need these bottom two rows, excuse me, rows go horizontal, columns go vertical. If I don't need these 2 rows, I can click on the number of the row like this. I can hold down the control key to select another row, and I can delete those. So I can delete selected rows, and now those are gone. So that's how you enter data into the spreadsheet and use it. Let's take a look at how to make your scatter plot. It's very easy. So in this spreadsheet, I've already entered data for 9 trials, which is really the minimum that anybody should have. So I have my car's mass that was my independent variable. So I'm going to click on that first. And then what was my dependent? Well, I have two dependent variables. I have distance and I have acceleration. So first, let's make a scatter plot of mass versus distance. So I'm going to click on B for column B. Then I'm going to hold down the control key and click E to select the whole distance column. Now see how they're both highlighted, they're both selected. Now go up here to insert and come down here to chart. And it has a little picture that looks like a column chart next to it. And click that. And look at that, it automatically made a chart. Now, if what you see is not a scatter plot, which this is a graph that has several points plotted on it. If you don't get a scatter chart, then you can click chart type up here under setup. This is your chart editor. Whenever you're selected on any kind of chart, pie chart, column chart, scatter plot, this chart editor will pop up and you can change everything on the chart here. So if I wanted a different kind of chart for this, like a line, then I could do that. That's not what I want. I do want a scatter chart or a scatter plot. Now, this is pretty good at automatically selecting your ranges for your horizontal axis and your vertical axis. If you need to adjust those, you can. You would do that here in Customize. So if you wanted to change, say, the range of your horizontal axis, like say I wanted to start it at 0 instead of starting at my lowest mass, then I would click on horizontal axis and I can put in minimums and maximums. And you can do that for everything on this chart. You can also change the titles of your chart, of your horizontal axis, of your vertical axis. You do that here under Customize, Chart and Axis Titles. But I like this because I have really good column headings. It's just using my column headings as my axis titles, which is great. This is even a decent title for my chart. I can leave this as is. The last thing I want is I want to add a best fit line or a trend line. And the way you do that is you go to series. Series means your series of data points. So if we go to series and we scroll down, there's 3 checkboxes here. Click the one for trend line and it automatically inserts a best fit line for your chart. Now these variables are going to have a linear relationship. Depending on how accurate your data are, you might see more of a linear relationship or less, but we want to keep this type set on linear, but you could change it to other types of functions. We're going to keep it on linear, and you can also make it show you the equation for your line. Here under label, change that from none to use equation, and look at that. It shows me the equation of my line with the slope and the y-intercept. Pretty cool, pretty cool. So that's how you make your scatter plot. You're going to do the same procedure to make another one for mass and acceleration. Watch this, insert, chart, change this to a scatter, go to customize, series, add my trend line and the equation, and that's my scatter chart for mass and acceleration. So that's how you do that. If you want to change your title to make it say mass versus acceleration instead of acceleration versus mass, that is fine. But that's how you make your charts. Pretty easy.